In the first part of this video on inheritance and polymorphism, we will explain what characterizes inheritance relationships and provide a simple example of a superclass with two subclasses. We begin by distinguishing inheritance relationships from composition and aggregation relationships. Recall that composition and aggregation relationships exist when there is a has-a relationship between two classes. By contrast, inheritance relationships are characterized by an is-a relationship. We say that the subclass object is a superclass object. These two classes are also referred to as the base class and derived class respectively. In addition, they are also described as the parent and child classes respectively, to reflect how they are arranged in the inheritance hierarchy illustrated by a UML diagram. Inheritance relationships are discovered during object-oriented design. They are the result of the process of classification. A familiar example of classification is the taxonomy of living things from biology. One reason that the term inheritance is used to describe these relationships is because the subclass inherits two kinds of components from the superclass. First, all instance variables are inherited. Second, all instance methods, with the exception of the constructors, are inherited. Now let's examine the Java syntax that is required to define inheritance relationships. The verb that the Java designers chose to express the inheritance relationship is the reserved word extends. The syntax rule for the class header is the following. The reserved word class, followed by the name of the subclass, followed by the reserved word extends, followed by the name of the superclass. In this notation, the reserved words, which are terminal symbols, are shown in blue. Red is used for non-terminals, in this case placeholders for the actual class names. In black are meta symbols. The brackets convey the fact that the extends clause is optional, which should be obvious given that none of the previous examples had one. The reason that extends was chosen to express the inheritance relationship is that the subclass extends the superclass in one of several ways. It can add instance variables and constants, it can add instance methods, or it can add both. Here is the UML diagram for the example that we will consider next. Student is the superclass and it has two subclasses, undergraduate and graduate. Note the symbol used in UML to express inheritance relationships. The line connects the subclass to the superclass with a hollow arrowhead pointing to the superclass. Let's check whether these classes meet the is-a test. An undergraduate is a student. A graduate is a student. To be more specific, an undergraduate student is a student. It is not unusual for the subclass names to involve an adjective modifying the superclass. It is always true that for any adjective and noun, adjective noun is a noun. We begin by examining the code in the superclass student. This class is intended to maintain the grade record for a student, so it contains two instance variables, one for the number of credit hours earned and a second for quality points, which contains the value computed as the product of the credit hours for a course and the numeric value of the grade earned in that course. Notice that both are initialized in their declarations, so an explicit constructor is not required. The default constructor will suffice. Even the initialization to 0 is just for emphasis because all instance variables are initialized to 0 by default. This example serves as another illustration of why reflexively adding get and set methods on every instance variable is a bad idea. These two variables are not independent. A class invariant is that the quality point should never be more than 4 times the credit hours. Allowing methods to independently set those variables could break that invariant. Instead, the method should reflect events associated with influencing a student's grade record. The primary event is when a student completes a course, which is why we have the method course completed. It accepts the number of credit hours of the course just completed and the numerical equivalent of the grade earned. It adds the credit hours earned to the total credit hours and adds the quality points earned for that course to the total. We have elected to provide one GET method to allow inquiry about the number of credits that a student has earned thus far, but not one for quality points, since it would be of less interest. Instead, the other accessor method we included, compute GPA, returns the student's grade point average as the quotient of the quality points and credit hours. Notice that since both of those values are integers, it is necessary to typecast one of them to be a double so that floating point division rather than integer division is performed so that the remainder is not lost. Next, we consider one of the subclasses, the undergraduate class. Notice first the fact that an extends clause appears after the class name. This subclass extends the superclass in two ways. It adds a constant for the minimum GPA required for an undergraduate student to be on the Dean's List. It also adds a method on Dean's List that returns a Boolean value indicating whether the student has a high enough GPA to be on that list. Notice that this method is able to call the method compute GPA without any qualification, because this method is an instance method of this class that has been inherited from the superclass. Next, we examine the other subclass, graduate. It extends the superclass by adding a constant required credits that defines the number of credit hours required for a master's degree. In addition, it includes a method that returns a Boolean value indicating whether the student has met the minimum requirements. To have a complete program, as always, we need a class with a main method. For this program, the class student_main serves that purpose. It first instantiates a graduate student object, then calls the course completed method to indicate that this student has completed a 3 credit hour course with an A, and then calls the meets master's requirement method to determine whether the student has earned enough credits for a master's degree, and then displays that result. Next, an undergraduate student object is created, and method calls are made to indicate that the student completed 2 3 credit hour courses and earned an A in the first one and a B in the second one. It then calls the on Dean's List method to determine whether the student qualifies for the Dean's List and displays the result. Running this program, we see the expected results, which is that false is output in both cases. We conclude the first part of this video on inheritance by summarizing some key points about how inheritance is implemented. First, the UML diagram for the classes involved in inheritance form a hierarchy or tree structure, where the superclass is at the root of the tree. The reason that these diagrams are always hierarchical is because in Java, every subclass can only extend one superclass. Programming languages with this restriction are said to only support single inheritance of classes. Some languages, like C++, allow multiple inheritance of classes. Because multiple inheritance of classes results in a number of complications, the designers of Java decided not to permit it. We will see in a later video that Java does support multiple inheritance of interfaces, which causes fewer complications.